For centuries, people have gazed at the night sky and imagined what it might be like to live among the stars. What would it be like to look back at Earth from a permanent home in space? Would we see borders between countries? Could we see the seasons change? Could we eat and breathe, and sleep and work? How would we feel? And how would our bodies react with no gravity to hold us in place? Do the laws of science behave in space as they do on Earth? How can we answer these questions, and what do they mean for the people of Earth? Since November 2000, not a day has passed without humans in space, orbiting more than 200 miles above our planet. They live and work and conduct scientific research to answer these questions and many more like them. They are scientists, but also construction workers and technicians, repairmen and teachers, cleaners and cooks. During the past decade, 15 nations have come together, setting aside boundaries and differences to design, assemble, occupy, and conduct research inside and outside of the largest and longest inhabited object to ever orbit the Earth. This is the story of their efforts. This is the story of the International Space Station. As early as the 19th century, writers and artists and scientists around the world began to publish their visions of a crewed outpost in space. In 1869, author Edward Everett Hale penned The Brick Moon, a short story about a satellite built from 12 million bricks. At the turn of the 20th century, Russian scientist Konstantin Tsiolkovsky proposed ideas about human spaceflight, including an orbiting space station. In 1923, Romanian math teacher Herman Oberth published a treatise that included an orbiting refueling station for a manned trip to Mars. A few years later, in 1929, Austrian engineer Hermann Nordung wrote of a giant wheel-shaped platform that rotated to produce artificial gravity. One of Oberth's students was famed rocketeer Wernher von Braun, who in late 1945 developed a concept for a modular, wheel-like space station that would serve as a launching point for a mission to the Moon. In 1952, von Braun published a widely read series of articles about space travel in Collier's magazine. In the early 1960s, as human spaceflight programs in the United States and Russia took shape, engineers and designers began to investigate a variety of space station concepts based on then-current technology. The Soviets were the first to establish an orbiting space station, Salyut 1, launched in 1971. In 1973, Skylab was assembled from unused Apollo rocket parts and launched to become America's first orbiting space station. 3 crews flew aboard Skylab for a total of 171 days on orbit, conducting a variety of scientific experiments and observations that demonstrated the value and the potential for space-based research. A temporary space station was created when an American Apollo Command Module spacecraft docked with a Russian Soyuz ship on July 17, 1975. Apollo-Soyuz was a viable example of international cooperation, the keystone and the foundation of the global partnership that would result in the construction of the International Space Station. With the launch of the first space shuttle on April 12, 1981, America resumed flying men and women into space.
We can follow our dreams to distant stars, living and working in space for peaceful economic and scientific gain.
In his Research Laboratory orbiting our planet. The International Space Station is the largest, most complex object ever assembled in space and is clearly visible from Earth with nothing more than the naked eye. From end to end, the station is slightly longer than an American football field.
The biggest shock, I would say, the biggest impact that I had during my flight is the first time I looked out the window of the orbiter and saw the space station. It was huge. It was huge and shiny and beautiful. And looking at it and knowing that a man-made structure that big is actually up there.
The interior of this incredible structure is larger than a 5-bedroom house, with 2 baths, a gym, and a 360-degree bay window. The station's mass is almost 1 million pounds, and it contains about 32,000 cubic feet of living space. The space station functions as a microgravity and life sciences laboratory, a testbed for new technologies, and as a platform for both Earth and celestial observations. The complex is made up of multiple interconnected modules, grouped together at the center point of a 357-foot-long integrated truss structure. Power is generated through 4 giant solar arrays attached to the ends of the truss. The pressurized components include 3 laboratories: the U.S. laboratory module Destiny, the European Research Laboratory Columbus, and the Japanese experiment module Kibo. The Russian service module is the structural and functional center of the Russian segment of the station. It provides living quarters, communication systems, an exercise facility, and flight propulsion systems. Other Russian segments include the functional cargo block, 2 mini research modules, and a docking compartment. The Italian Space Agency provided a permanent multi-purpose module, which can host up to 16 additional racks containing equipment, experiments, and supplies. There are 3 modules called nodes that connect the elements of the station and provide berthing ports. The primary residential areas include the Russian service module and Node 3 Tranquility, which contains a bathroom for crew hygiene and exercise equipment, a treadmill, and a zero-G weightlifting device. The Quest airlock provides the capability for extravehicular activity, or EVAs. This is the module that provides the exit for spacewalking astronauts to go outside the station to work. The cupola is a small module designed for the observation of operations outside the space station. Similar to a bay window in a home on Earth, but with a 360-degree view, the cupola allows crew members to observe the approach of vehicles, as well as all robotic arm operations and spacewalks. The Canadian-built space station robotic arm is a larger version of the arm on the space shuttle and is used to move equipment and hardware around outside the station. The space station is the home of 6 full-time crew members and is made up of astronauts and cosmonauts from nations around the world. More than 200 people have visited so far, and at least another 120 will live there over the next decade. The space station's modular design was dictated in part by the launch vehicle payload bay size of the space shuttle and the need to make components maintainable, replaceable, and sized to fit through a hatch. Each of the components that make up the station was designed, engineered, and built in manufacturing facilities and factories in countries around the world, and assembled piece by piece for the first time in space.
When I talk to folks all over, I mention that none of these parts have been put together on Earth, and I think they all stop and go, wow, that's pretty incredible, because when they get up to space, they all magically fit together, which means the cooperation on the engineering and technical side is really working.
Building the International Space Station required 36 space shuttle flights and 5 Russian Proton rocket launches to ferry each space station component into orbit. Working in a dangerous and hostile environment while orbiting the Earth at 17,500 miles per hour, spacewalking astronauts and robotic arm operators carefully assembled the components. In elegantly choreographed ballets, astronauts operating the Space Shuttle's arm and the space station's arm lifted the station modules and trusses from the shuttle's payload bay and maneuvered them into place. Astronauts and cosmonauts in pressurized spacesuits then attached the components to the station during nearly 160 spacewalks.
The International Space Station is a little bit more unique because people are actually living and working up in space 24 hours a day, 7 days a week, 365 days a year. And what that means is that there's a myriad of people on the ground all over the world making sure that every aspect of that spacecraft is working correctly and the crew on board is healthy and safe.
Ground operations for and management of the International Space Station are like running a marathon, not a sprint. Overall coordination of space station operations takes place at the Christopher C. Kraft Jr. Mission Control Center in Houston, Texas, and the Russian Mission Control Center outside Moscow. These control centers oversee the U.S. and Russian segments of the space station. At each control center, a team of flight controllers is assigned to monitor each of the different systems and research facilities aboard the space station. The flight controllers answer to the flight director, the leader of the flight team, and the person responsible for overall mission success. The flight director communicates with the station crew through the Capcom, or spacecraft communicator. The Capcom is frequently an astronaut. To provide round-the-clock systems monitoring and also flight crew access to the ground team at all hours, 3 rotating sets of flight directors and controllers work an overlapping 9-hour shift in an intricate schedule covering all 24 hours of the day, 7 days a week, 365 days a year. As the space station has expanded with equipment and crew launches from Florida and Kazakhstan, other launch centers and module control centers have been added to the global space station family. There are additional control centers in Huntsville, Alabama, and St. Hubert in Canada. The European Space Agency operates locations in France, French Guiana, and Oberpfaffenhofen, Germany. The Japan Aerospace Exploration Agency manages its operations at 2 sites within its home country. During the assembly phase, the Space Shuttle and the Russian Soyuz spacecraft have been the workhorses to deliver space station supplies and research samples, and later crew members to and from the space station. Supplies are also delivered to the station by unpiloted spacecraft. The Russian Progress, JAXA's H-2 Transfer Vehicle, or HTV, and ESA's Automated Transfer Vehicle, or ATV. After NASA has retired the space shuttle, astronauts will catch rides in the Russian Soyuz spacecraft to continue the U.S. presence aboard the station. U.S. commercial spacecraft, currently in development, will eventually deliver astronauts and supplies to the station. Each flight aboard the International Space Station, called an expedition, lasts about 6 months. Similar to a temporary overseas assignment back on Earth, astronauts communicate with their families by telephone, email, or the internet, but are still away from home for an extended period of time. This rotating mixture of astronauts and cosmonauts, representing 5 different space agencies, trains between 2 and 4 years prior to launch. The training facilities for astronauts and cosmonauts are located in Texas, Russia, Canada, Germany, and Japan. The habitation and life support systems provide a safe, comfortable, and livable environment in which crew members can conduct scientific research. The amenities include quarters for eating, sleeping, and exercising, environmental controls, medical and health support, and computing and data management. There is also a state-of-the-art recycling system that scrubs the air and liquid waste for reuse. But what is it like to move to space and live 240 miles above the Earth for months at a time? Crew members exercise to maintain muscle and bone strength, communicate with family and friends back on Earth, spend time sightseeing, and get together for dinner.
And you're sitting there having a meal with Russians, Germans, French, American, African American, Asian American, this whole melting pot of people working together for the common good of our civilization.
Of course, living in microgravity is not all work, no play. Although the station is equipped with 2 bathrooms, bathing can present a challenge.
When you're up living on the International Space Station, you might be 6 months without a real shower. Essentially, you have a sponge bath is what you do every day. And yeah, you do get pretty sweaty because you're working out. But surprisingly enough, when the shuttle crew came to pick me up, was one of my first questions, do I smell? And they said I didn't smell, and they said my hair didn't look greasy, so I was pretty happy with that.
I think the ISS is the greatest human endeavor ever in the history of the world in terms of complexity and the challenges that are brought with that complexity.
2 decades ago, the Cold War was still going on, and here we are working with the Russians, the Americans, the Japanese, the Europeans, everybody working together, and it seems that it's a far better thing to be doing than we were doing 60 years ago. It gives us the chance to do programs that we couldn't do all by ourselves, and it gives us the chance to learn how different people work, how different cultures work together, and how we can cooperate and produce something as magnificent as the ISS.
It's one small step for man, one giant leap for mankind.
Like stepping on stones across a stream, humans have started to take small steps across the universe. In the stream of time, the International Space Station is just one small step. All the lessons, good and bad, that we learn on Space Station will benefit us as we look toward longer missions away from Earth. Some of the biggest lessons learned from the design, development, and assembly of the International Space Station are those of peaceful cooperation among nations.
It would be impossible for any single country to do what we're doing here on Space Station. But as a team, we're pulling for a higher good, and that higher good is to learn to explore, to learn to push frontiers, to learn to move out. And that's really what cooperation brings us. And I can't think of a better example than Space Station when you look forward.
Humans will continue to explore in low Earth orbit, on journeys back to the Moon, to Mars, to asteroids, and beyond. But wherever we go, the International Space Station is improving our lives on Earth now and cementing our first real foothold for working and living in space.
I guess you're about the only person around that doesn't have TV coverage of the scene. That's all right, I don't mind a bit. They've got the flag up now, and you can see the stars and stripes on the lunar. Flag up now, and you can see the stars and stripes. Are you getting a TV picture now, Houston? Neil, yes, we are getting a TV picture. You're in our field of view now. That's one small step for man, one giant leap